Welcome, everyone. Thank you for joining us for today's Fiber Broadband Association webinar. Today's webinar is titled The Pros and Cons of Network Architectures, and it is being presented by Hexatronic. I'm David Norse, webinar producer here at FBA. Before we begin, I just have a couple of quick housekeeping items to go through to make sure everybody has a great experience today. First of all, you are in listen-only mode as an attendee today, but we do want you to ask questions. We encourage that. So use the questions tool, which is located in the upper right corner of your screen. It's the quote box that has a question mark symbol in it. Use that and you can type in your questions, and we'd love to hear from you and answer those questions once we get to Q&A at the end. Also, this is being recorded. That recording will be available on the FBA website under the events heading. If you go there, you must be a FBA member to view the recording from there, and you must have credentials on the website, but we will post a link into the chat that will take you to the place where you can sign up for those credentials if you need them. And lastly, we do have a survey at the end of today's webinar. It's a one-question survey, very quick, but it's super helpful for us. So please do take a moment to do that survey. And with that, let's dive right in. So today, we're going to be talking about fiber to the home networks and how they've evolved. Early fiber to home networks really mirrored the architectures that were employed already by the telephone companies over the past few decades. And of course, consumer needs and demands have changed over the years, and fiber to the home architectures have evolved as a result. Today, we're pleased to have Chad Johnson, network architect at Hexatronic, who will be discussing the different fiber to the home architectures and their advantages and their different challenges. And so without taking up any more of your time, Chad, I just want to say welcome, and I'll hand things over to you at this point.
Yeah, thank you, David. Sincere gratitude to you for helping me pull this together. Thank you to the FBA for making webinars available to our industry, and thank you to Hexatronic for allowing me to sit in and do this. Lastly, I'd like to thank everyone who's taken their time out of their busy schedules to come hear what I have to say about the architectures of the past, the current, and future. I've been lucky, throughout my career to have worked in the telephone industry, the cable TV industry, and for fiber overbuilders. So I've spent 26 years in the industry on the service provider side. Recently moved over to the vendor side of our industry with Hexatronic. After being a customer for years, I just really was drawn to the philosophy and how they treat their customers. So I've been with them since the beginning of the year. A lot of what I'm going to talk about today has been my experience over the last 26 years on the service provider side, though. So like I said, I've been on the telephone side with ILEC telephone companies, small and major MSOs, fiber overbuilders from large companies to startups in the private equity realm. I've been a part of teams. This is not just me. So, either me being on the team, leading teams, I've built hundreds of thousands of homes passed with every architecture that I'm going to talk about today. So I'm lucky enough to be able to explain kind of the pros and cons of each of those. I've participated in product innovation committees with a lot of the major suppliers in our industry. And the philosophy, what drew, I said a little bit about it, of what drew me to Hexatronic was the philosophy on how they handle relationships with their customers. So as we go through the agenda, we'll go through a list of architectures. I'll try to get through those fairly quickly. I can offer a cost analysis breakdown over the airborne fiber type of architecture that Hexatronic offers versus some architectures of the past. I'll offer some insight into considerations whenever you're making architectural decisions with your outside plant. I'll briefly hit on some field support that Hexatronic offers to their customers, and then we'll do a Q&A. So I look forward to getting to the Q&A section. I first want to start, though, that nobody is deploying fiber today the wrong way. There's FBA has done a good job at explaining all the benefits of a fiber optic internet service for the customers out there. There's not a wrong way to do it as long as we're building fiber to the end customer. There's better ways, but there's not a wrong way. Let's see. There's some architectures that I didn't include in this that that we can talk about, but I'm not going to cover them in detail because they're not as pervasive or widely deployed as others. And then there was some questions on the active components within the network architecture. This is going to be really geared to the passive part of the network. And I'll hit on a little bit of that active stuff. Opinions, there was some questions around 10 gig, 25 gig, 50 gig that I can speak to in the Q&A section. So if we go to the next slide, David, we'll start with kind of this home run architecture. This architecture was one of the first ones that that I was able to see in my career, and there was a major decision that service providers had to make. Do they go active Ethernet and provide that 1 gig that was the buzzword when fiber started, or did they go this APON BPON route, right? So you couldn't get anywhere close to a gig either download or upload whenever BPON was a thing, and it wasn't till GPON to where the passive kind of deployment really started to take off. So this home run portion is very much like a telephone network. You have a central location where the electronics are, and they build a fiber connection from the central location out to each customer. That was really expensive to do. A lot of material involved with the fiber, a lot of big conduits, and a lot of fiber splicing that took place here. So the industry, as they started to build out more fiber throughout their networks, was really looking how do we reduce cost, and so PON really started to take off whenever the demand grew beyond just the local telephone companies needing to build fiber. If we go to the next slide, this is where the centralized split came in. So what this did for network operators was it reduced the amount of fiber that was needed from that electronics point out to what we know today as an FDH, or it was often referred to as a splitter cabinet. Those cabinets are still deployed today, and vendors have done innovation and figured out how to get those into an underground solution. And so now there's below grade FDHs that find their home in a handhole, and above ground options that are in a cabinet. So this technology really reduced the F1 fibers in the network. So the one fiber is needed from the OLT out to each splitter. Now that splitter comes in a wide range of split ratios. Commonly used today are a 1/16, a 1/32, and a 1/64. There are companies out there that are deploying a 1/128 split. Optical loss is something that needs to be considered whenever you're into those 1/64, 1/128 split ratios. Let's see, this was a, as PON developed, the electronics manufacturers have done a very good job of keeping up with the demands of speeds. Like I said, there was an APON. I really wasn't part of the APON group. I kind of came into the industry around the BPON phase. I have the experience with BPON, GPON, 10 gig, um, 25 gig and 50 gig. 50 gigs gonna be the next standard for PON technology. Um, so this architecture offered some cost relief to the network operators as they were building out their networks. They saw that cost relief in the portion of their F1 or from the OLT to the location where they were doing the split. If we could go to the next slide, please. So then, as fiber continued to gain traction, fiber to the home continued to gain traction. Service providers were, how do we further reduce cost? How can we get fiber out to more people and still reduce the cost? So centralized split gave that cost relief in that F1 portion of the network, so from the OLT to the splitter. And then distributed split came along. This was again innovation from the vendor community, and so in this architecture, it's often seen here. Here we have it drawn out as a 1x8 splitter that then feeds 1x4 splitters. So now a lot of the cost relief has been given in the F2 portion, or the portion of the network post first splitter. Most distributed split networks, are some sort of variable of 32. So in this scenario, you have the 1x8 to 1x4. Oftentimes we see companies that want to utilize a 1:64, and they can very simply do that by placing a 1x2 close to the OLT. That really doubles the that 1x32 split ratio on the PON port. These splitter arrangements can be placed in two locations, like they are here, or they can be placed in many locations throughout that F2 portion of the network. So this again, drove down the deployment cost, and this has been an architecture that's been around for a while. It's still being deployed today. This can be split in splice vaults that a technician or would go into a splice location and splice in their drop, or it can be done with terminals. If we go to the next slide, please, we have I'd say an architecture here in distributed tap that's not as widely used. This is really kind of over the last several years that this architecture has kind of taken root. Just like the centralized split architecture was similar to a copper telephone network, the distributed tap network is very similar to the way a cable TV network works. So, there's light or power that leaves the electronics, and a portion of that is carved off to service the homes in the area. Um, as we can see from the schematic, we have a 90-10. So what that tells us is it's working like a directional coupler. It's directing 10% of that power off to service those homes while passing 90% of the power through, and so on and so forth. So there's like I said at the beginning, there's other types of architecture. There's a fiber harvesting type of architecture that really crunches down the the number of fibers that are needed, and they're reusing fibers. And it really becomes a nightmare in tracking your fiber inventory. And we'll talk a little bit more about that as we get to the pros and cons. Um, David, I think we're at the point to have our first poll question of this webinar. If you could throw that up there.
Absolutely.
Yeah. So what? Go ahead, David.
Oh, I was gonna hand it back over to you. We have
Oh,
some
okay.
results in here.
Yeah. So the question is, are the service providers that are in here, or the construction contractors, are you building the fiber network today in the same manner as when you started, either architecturally or through the same construction methods?
All right, we've got some numbers coming in. We'll give it another second here,
Okay.
and we'll share these results. All right, so we close the poll. Looks like 37% are saying yes, but vast majority, 63%, say that they are not building the same as when they started.
Excellent. Okay. Yeah. I mean, I haven't built the same throughout my career either. So what we're going to go into after this poll is I'm going to ask if David could share a video with you. Actually, I'm going to talk about it first, and then we'll share the video. So this is going to be new to a lot of people on the call. It was very new to me in some regard. Uh, at my time with a large fiber builder, I was introduced to the construction method of microtrenching. So that's where I originally got kind of my feet wet with microduct. Um, Hexatronic has been deploying microduct technology for well over a decade in Europe. This is tested, true, tried and true to as a deployment method in all types of climates. We in the U.S. don't like change very much, and it took me a while to initially wrap my head around this. So I'm gonna do my best to explain this to everyone. This is a localized serving area. So what we have is an FDH, and it could be a cabinet above ground or a below grade FDH in a vault, similar to those that you've known from the past. And this builds a microduct pathway to each home within a serving area. So the optimal serving area that Hexatronic has developed is 96 homes. Um, so from this location, there's a 7 millimeter OD to a 3.5 millimeter ID microduct pathway that's created from the FDH to each home. Comes in a lot of different bundles, as you can see to the right, from a 1-way up to a 24-way. As we refer back to the architectures that I went through, the industry moved off of centralized split because of cost. They were looking for a way to drive down that home's pass cost uh, even more than they were from the home run, right? So this localized service area brings us back to that centralized split um, type of architecture, but it's very localized. It's not the 288 cabinets, the 432, the 576s that we've all known from the past. This is a smaller serving area of up to 96 homes. So this is dramatically reduced the cost of what it takes to build a home pass. So the F2 portion that we talked about, through whether it be distributed split or centralized split, it's non-existent in the localized serving area architecture. We build fiber to the FDH where our splitters reside, And then we build a microduct pathway, to the home. So there's no fiber in this portion of the network day one. There's no need for service providers to spend that money on splice enclosures. There's no reason for service providers to spend that money on fiber, on the labor associated with those tasks of splicing or setting vaults. This is like building a plumbing system for telecom, and we can utilize that pathway to blow air-blown fiber through there. Um, this is, I wish at times in my career I would have had a conduit or a series of conduits that I could utilize. Um, and this answers that call. David, if you'd play the video, our video here does a fantastic job explaining this. Thank you very much, David. All right, if we can pull the slide deck back up and hit the next slide. So this is an analysis that a build cost analysis that has been done, and what it does is it compares a traditional centralized split architecture utilizing fiber terminals to the localized split architecture utilizing air-blown fiber. Um, as we see from the schematic here, that there's a 54% reduction in material cost. The fiber deployment on day one in the F2 portion is non-existent. That's a big savings right there. The connectivity portion is a major reduction due to not needing those enclosures or the terminals within this. Uh, yes, I got a note, David, from somebody that there was no audio on their video, and we will provide a link. Um, so, as far as whenever we get to the F2 portion of the network, there's a lot of material that's not needed day one. A lot of the network builders, especially fiber overbuilders, have a penetration rate target that they're looking for. It's not 100%. I think they'd love to have 100%. Their target is far below that. So, I think as spending a lot of time in the network operator world is, why would I want to spend the money day one and never have that part of the network utilized to bring in revenue for the company. So on this slide, we'll also see that the labor was reduced by a modest 21%. This happens because there isn't a need to place vaults. There isn't a need to place splice closures. There's not a need to place the fiber or splice those fibers. So the fiber splicing is really limited in this to the fibers that need to be spliced to feed the splitters for that FDH cabinet. If we could go to the next slide. So everybody says, well, if you don't put in the fiber day one, you have to put it in for the customer. That's true. But all these dollars spent at that point are spent on a success-based CapEx scenario. So the connected home costs are going to be higher than a traditional. We see a materials rate at 44% higher than the traditional way, and we also see the labor increased, and that's because that's when we're putting in this fiber into this portion of the network. The investors, CEOs, CFOs, really like this model because they get to defer their capex to whenever they have a revenue generating unit on the network. If we could go to the next slide, please. This is kind of a snapshot that sums it up. This model was drawn out to 100% penetration. I don't know that there's a network out there that has 100% penetration. If there is, kudos to you. Something's going crazy. I know there's some networks that are look at MDUs and stuff, and they do contracts with that. But network wide, for the vast majority of folks deploying a fiber network, they're far below 100%. If you get to 100%, nobody's going to question what you're doing anyway. That's my network provider side of it. Secondly, or what I'd like to point out on this slide is if you do get 100% penetration, an air-blown fiber model still is a 20% reduction in CapEx. What this doesn't take into consideration is I would argue that it's actually more than 20% if you take the time value of money and involve that into this calculation, because not all 100% of those are going to come on board day one. So if we could go to the next slide, and I'll spend some time on this one. This is a good slide that shows kind of different areas that everybody likes to talk about building fiber. Me being somebody that had to operate the network after it was built, it really matters how the network's built. A lot of folks say, hey, we build a network and then it's done. We don't have to worry about it anymore. And that's just simply not true. We still have to maintain it. We still have to do troubleshooting. We still have, fibers that are cut that we need good records, in keeping that. So, as we go from top to bottom, it really brings out, and this is opinion based. So I welcome anybody to try to poke holes in this. It's a good discussion to have. The amount of fiber required, for instance, if we start at the top, a home run requires more fiber than any of these other architectures that we've talked about today. By not having F2 fiber and that drop really being replacing the F2, we can say that an air-blown fiber architecture is the best choice as far as the amount of fiber that's required. OLT port utilization. This is one that is often not considered whenever we we talk about architectures. From my experience in this localized, because we've shrunk down that serving area to 96, we got a lot more utilization when it comes to our FDH cabinets and our OLTs. So, we see somewhere in the, hovering around the 90 to 92% utilization out of a FDH. My experience by using a distributed split, it's far less than that. It's in the 75 to 80% utilization. Oftentimes you have a 4-port terminal or a 4-port splitter out there that you have one house. So you just lose a lot of utilization on that PON port. And that just, snowballs on you. We'll talk more about the PON port utilization in a couple slides, but engineering complexity, it's super easy to engineer from point A to point B. So that, home run or, the air blown fiber architecture is a lot easier for engineering. It's really rinse and repeat. Flexibility and the ability to upgrade your network. I got into a position in deploying distributed split architectures, and I think I'm getting into our next poll question here a little bit, but the flexibility that you have there is difficult. Once it's there, it's there. So the flexibility to add more to it is difficult. The amount of splicing required, this one home run is brutal when it comes to splicing fiber, and it does get better as we progressed through the different architectures that are out there. Time to build. There's a race going on in the first customer to get to a home passed with a fiber connection. I often hear that first fiber offer or service provider to a home wins. The fiber's resilient, the connection's great, and they really don't lose that customer. So time to build is critical in how we're building these networks. And then the time to turn up a customer, this is really kind of the same across the board. We all have to put in the drop and do the install, and it's relatively the same with any architecture across the board. So this takes us to our second poll question, David, if you don't mind running that real quick. And that is, have you ever had to overbuild your own fiber network? I know I have several times in my career.
We've got results coming in here. We'll give it another second or two.
Okay.
All right, we'll go ahead and close this poll and share these results. And it appears that you're not alone in having to overbuild your own network.
Yeah. This is this is one that I couldn't ever plan enough. And if I took the lead of what vendors told me years ago is, just double the capacity of your fiber. Well, that's easy to say when you're not having to write the check for that fiber. And in some instances, I don't know if doubling the size of the fiber I put in would work. Right before, I can't say that I did it, but right before I ended up at a ILEC telephone company, when I entered the industry, they had put in an 8 fiber cable to connect to telephone exchanges, and they were told by the vendors, 8 fibers is enough. You'll never need any more. We as a company overbuilt that with a 144, and I'm not sure if that was enough. Um, so if you could go to the next slide, please. So I think, yeah, one more. There you go. So I think that brings us to what's next for the fiber to the home networks. I know I've seen it change throughout my 26 years in the industry, and it's been a dramatic change. And I've been lucky enough to be along on this ride and see these changes. Um, this is an expensive thing. There's a lot of pressure to continue to reduce the cost. I frankly, many of you on here know that the materials portion of building a fiber network is the small piece of it. The labor's expensive. The construction's expensive to place these cables in the ground. So several years ago, I made the decision I don't know what's next. I have a fiduciary responsibility to the companies and boards and ownership that I'm working for to spend their money in the best way possible. And I made the decision I didn't want to overbuild myself ever again. The only way to do that is to really put a pathway into every parcel that I'm passing. In this scenario with, take 5G, small cells, if you're going to offer backhaul for that, at some point in time, um, we're going to need connections out there in the right of ways, whether it be for autonomous vehicles, for security cameras. A gaming center comes up and needs, a massive volume of bandwidth. And yeah, some of this stuff we can do electronically, but it gets expensive that way as well. So, if I told you you could put a very small pencil size 7 millimeter microduct in there and blow up to a 24 fiber through that, I think all of us would rejoice. It takes out of the equation is this lot going to be a single family home or a duplex? Is this larger lot going to be, an 8-unit apartment building, or is it just going to be a house? Those are the things that are real world, that we run into as service providers, and it is crazily expensive to go back and do construction. So David, if you could go to the next slide, please. So things to consider when you're choosing your passive architecture. We talked a little bit about that OLT efficiency. Um, I often hear, well, an OLT port is cheap in the entire scheme of things. Okay, I agree. It can be. This is really kind of an unfair statement, and one that's not looking at the total landscape of building a fiber network. By having a low utilization on your OLT ports, you need larger active cabinets, or huts, whichever one you're deploying. You need more of them, which is a fun ask when you're going into any community. Is, hey, I want to set these big OLT cabinets all over your community. More power is needed. You have more electronics out there consuming power, and that, frankly, that's not getting any cheaper, and that's an OpEx hit. So you're kind of, you know making that statement, well, the OLT port's cheap. Yeah, it is, but it's one that's going to keep hassling you for years to come. By having more OLTs and more OLT ports out there, you have longer upgrade and maintenance times. So you have your overnight shifts working even longer to provide upgrades to those electronics. Um, if we dive into the flexibility, I think I hinted to this a little bit earlier when I was talking about distributed split. Um, I've heard leadership say in the past that, hey, whenever we get done with this area, well, we're never going to be done. There's always going to be plant extensions. There's always going to be homes being built. Um, Life around just happens, within these networks. So having the flexibility to be able to put a 2 fiber drop into a single family home or a 24 fiber drop into an MDU, that's the type of flexibility that I like to see in the networks. Many of the network operators are upgrading their old copper networks, and they're utilizing conduit pathways that they have had in the past. They're being able to do this quickly. Well, guess what? That's a flexible network. The areas where they decided to not put that pathway in and direct bury the phone, guess what? Now they're spending a lot of capex dollars to go in and put fiber in where they would have had the flexibility of a conduit if they would have done that in the first place. I think, I can say that you'll be happy to have that pathway in place when and if fiber's needed to that area. Troubleshooting. This is one that often isn't thought about. The shared networks are difficult to troubleshoot. Home run architectures are great, right? You have that single path from point A to point B, and you can troubleshoot that. That especially on the active E side, you have that one-to-one relationship with a transmitter receiver and the ONT. That's probably the easiest fiber network to troubleshoot. When we get into these passive split networks, they become more troublesome to troubleshoot. So I like the fact that the localized service area is really that point A to point B troubleshooting scenario. You go from the electronics to, and centralized split is very similar. You go from point A of the OLT to point B of the splitter, and you can, quickly and easily look at that portion of the network. Once you start getting into the F2 in the localized service area, that's your drop. So that's an easy troubleshooting spot too. The distributed split, it introduces more issues whenever you're doing troubleshooting, because where are the splitters? How are they labeled? Which splitter is this customer on? So that brings me to the next point of record keeping. A point A to point B is a whole lot easier to keep as records in whatever system of record you're using. I'll say I'm going to take a wild guess that somebody is still using Excel spreadsheets for that, as I know I did as well for a lot of years. So being able to keep those records, these companies are going to be valued on what kind of networks they have, and if there's an acquiring network or an acquirer that's looking at your network and you can't tell them what you have out there, that is going to decrease the value of your network, because they're not going to know what you have. If you have great records and can say, here's everywhere I have, here's the connections, they're going to say, wow, this company really has their stuff together, and they're not going to dive deeper into that record keeping portion. So David, if we could go to the next one, I'm going to try to hurry through these last 3 slides so we can get some Q&A in. The key takeaways, and these are on a one-click, David. So building fiber is key. Like I said, whenever I came in at the beginning, there's not a wrong way to build fiber. There's better ways, and hopefully I've been able to share some of the reasons why there's better ways to build these networks that are going to be easy and fun to operate. Or easy might be a crazy word. They're going to be better to operate over the next 20, 30, 40 years. Than if you're always having to go back and try to add in and figure out how you're going to modify your network for growth that's happening around it. Change is going to happen. I think the poll question, that was out there, we're not doing this the same way as when we started. I sure evolved in my thinking of how I was going to deploy a network, and keeping an open mind. I think appreciating the things that things are going to change was critical, and always learning from those around me. Um, we're as building networks, we're past the build it and they will come relationship that we once had with fiber. It was a very easy decision with some companies that I was with to go build fiber in an area. And the cable companies of the world that continue to innovate with hundreds and hundreds of miles that they have of coax out there. It's not a given that fiber overbuilders are going to take that customer. I think once they get it, they're going to have a very solid job of being able to keep that customer. But this isn't a given like it was in the past. So I think we need to just be mindful of what kind of network we're building and how we know the network's going to evolve. The key takeaway is we need to reduce the cost uh, per home passed, and that's really so we can build more homes. Um, you know, Building more homes with fiber is always a good thing, and so I think being able to lower that build cost is paramount in this next phase of fiber to the home build outs. Um, and I'd like to tell everybody on here is align yourself with a vendor, or vendors that present traits for being a good partner in your success. That was I mentioned that I was a customer of Hexatronic before I joined. This is something that they stressed, and I was used to being treated like a customer. Yeah, I had lunches and dinners and that good stuff, and great friends that I made on that side of it. But I really never experienced a vendor being a partner and concerned with the success that I was having, and offering ways to help that I did with Hexatronic. If you go to the next slide, David, I think this is a big piece of what Hexatronic does is they have a field support team. I don't know of any other vendor that does this, has this, offers it, but they have we here at Hexatronic have a dedicated support team that supports the customers and contractors through training. They actually go out to site and they train contractors on how to put together the best network for the service provider. That's amazing. I mean, who does that? Who spends? Often they sell, yeah, they're good customer service and making sure they get your PO and making sure that your product's delivered. But who goes that step further to make sure that your contractors are putting in the network that you're paying for? Still today blows my mind. They do post training follow ups on your network as a service provider to make sure the contractors you hired are putting in the network that you expect to receive. And they're 24/7 customer support. So whenever you have problems, that they're there to answer any questions, help you through any difficulties that you have. David, if you could go to the next slide, please. This is a couple pictures I wanted to share. This is a mock-up of a training facility, and then to the right, this is actual hands-on training that's taken place by this field service team. Kudos to them. And to the next slide, please. So this is where I get to end and offer 9 minutes for question and answer. I'd just like to close out by saying thank you again to everybody that's spent time with listening to me today. And we're going to be at Fiber Connect next week, so great timing on our part that we have an awesome FBA event coming up next week, and we're going to have a lot of the Hexatronic team at the event and the booth. Our director of site technology, so that field service team, he's going to be there. I'd love for you to have a chance to meet him and all the other great Hexatronic team members I have.
That's great. And Chad, do you happen to know your booth number offhand by chance for next week? If not,
I think it's in the 400s, David.
No problem at all. Well, we will help you find Hexatronic next week if you are at Fiber Connect, and we hope you are. We do have quite a few questions, though, that came in. I'd love to get through some of these. I think you might have a little bit of homework. There's been a lot of interest and a lot of questions coming through. But first of all, Chad, thank you. This has been fantastic. I know, in full disclosure, I was stealing some screenshots during the presentations. Well, some of the tables are great comparisons. So just to kick things off, somebody's asking how quickly the air-blown drops are installed.
Yeah.
And,
yeah, I think that came up in that video. So apologies for those that didn't get the audio. We'll make sure we get the link to everybody. But the drop blows in at 100 meters per minute. So it's pretty quick, and it's a one-person operation. So yeah, thanks for that question.
And I guess related to that question too, can you share the time it takes to pass homes with ABF network and then connect a subscriber?
Yeah, it's greatly reduced in comparison to other architectures that are out there. Really placing the pathway is placing the pathway, whether you're doing a more traditional 1.25 1.5 2-inch type of deployment, or you're doing a microduct bundle. You can bore this in. This will bore it. Open trench, plow. However, all the traditional construction methods. We have an aerial solution as well. Placing the pathway is very similar. Where you save the time is you don't have to set the vaults. So those heavy vaults that are out there, there's no need for it. The little Toby box that the video referenced, and you saw on one of the slides, that is a very small box. It's a couple shovelfuls to put it in. And really, it's used to locate the end of the microduct so your technician can continue the microduct onto the house. So the reduction in time really comes from not having to set the vaults, not having to place the fiber or splice the fiber to activate that portion of the network. So, we typically see in an area of 96 homes about a 3-week advantage. Because those are often different crews that are coming in to blow the fiber, and then a different crew to come in and put the splice closures on and do the splicing. So
great. And there's a question here: how do you repair cuts in the network?
Yeah, it's the technology is fascinating. I referenced this is similar to building a plumbing network. So what you have is we'll take for this situation, we'll say a 12 a 12-way microduct bundle. If it were to get cut, you would dig down, you would put in a piece of 12 pieces of microduct, and we have little connectors that are very similar to a shark bite plumbing fitting. You have a good clean cut on the microduct ends, and you push it in until it bottoms out in the connector, and you do that on both sides. It is a very quick restoration. And then for those, you would reblow the fiber from the FDH to the home. But you have to remember that that is just for your active customers. So in a traditional world, that fiber would get cut. You'd have to resplice all of those, whether there's anybody on the fiber or not. And we all know how expensive it is to get fiber splicers involved.
And so I think the answer to the next question was actually in your last answer a little bit, but somebody is asking for clarity here regarding the microduct. They're asking if the microduct is laid in and the fiber is not blown until the customer order. Is that correct?
That's correct. That's correct. We we don't feel that there's a need to install fiber in that F2 or drop portion. And I say it as F2 because that's how we historically know it, but it's really a drop in the localized serving area. And so that is all success-based CapEx at that point. You're only putting that fiber in when you have a paying customer.
Great. Let's see. What do we got? What do we have next?
I saw one here that is Hexatronic system compatible with open access networks.
Yep.
Absolutely. Some of the largest fiber overbuilders that have open access, they're using the Hexatronic product today. This offers the flexibility. So if you have an open access type of network, and it's a distributed split, once that first tenant comes in there, they tie up that OLT port, and there's different versions of open access. As the network provider, I maintain all the electronics, and you can use VLANs to put other customers or other ISPs on there. Or you can offer a dark fiber or a passive network to those ISPs. And with this scenario, we could effectively, by putting a 24 fiber in each microduct, there could be 24 different ISPs to one building. So that's some of that flexibility that I think is critical whenever you're making architectural decisions. And we've seen a huge uptick with open access providers interested in the air-blown fiber.
Great. And so this one actually just came in, but somebody's asking what the max distance to blow a drop is.
Yeah, so we don't typically run into an issue with max distance. It's because those serving areas are in the 96 home clusters. We really don't kind of hit our max distance, but the max distance is 1,000 meters. 3,280 feet for us that still do miles per hour in feet. So 3,280.
Okay. And I think we'll wrap up with just a general question. We had a few questions about this. People are just asking generally, what about aerial? Somebody is saying that their plant is 90% OH. So do you have any advice for aerial?
Yeah, I do. It's very similar to the underground solution, and I'm more than willing. I think my contact information's on the screen. Take a screenshot of it and feel free to reach out to me. The aerial is very similar to underground. It's microducts put in the air. We use a 19-way microduct bundle. Has a jacket on it, UV rated. We can put any of the squirrel deterrents or rodent deterrents in it, like any other cable. we have an aerial FDH that, we operate these on more of a 1x32 kind of FDH boundary. And what that does is it allows us to use 3 of those 19 ways as transport. And then we have 16 microducts going each way out of that FDH. So that's effectively your drop. I can, if anybody wants to reach out, come see us at our booth at Fiber Connect. We'll have an example there. We can show you it. It is a very fast and effective way to deploy aerial. Once you have the pull permits, and we all know that that's a sticking point for whichever architecture you want to deploy.
Well, I think we have to wrap up here. We're just out of time, but Chad, I just want to thank you again. This has been great, and thank you to Hexatronic for bringing us this information, and of course for sharing your expertise today. We really appreciate that, and of course we appreciate all of you taking time to join as well. Hexatronic does a great job training their customers. We want to help with that effort here at FBA, so we have our Optic Path program, which is about certifying the next generation future technicians, and we're actually seeking volunteers to help with that education. So if you think you have the stuff and really want to help build the future of fiber, we encourage you to follow that QR code, and please reach out to us or see us at Fiber Connect. We'd love to talk to you about that. So if anybody's interested today, please do that. And of course, no surprise, we have Fiber Connect next week. We're looking forward to seeing Hexatronic there, and many of you there as well. If you haven't already registered, but you're still considering it, I'd encourage you to go out and do so probably today. We are expecting the largest turnout yet for these events, and we'd love to see you there in Nashville at the Gaylord next week. So looking forward to that. And then following the Fiber Connect show next week, we do still have several regional workshops that are coming up. We'll be in Des Moines, Iowa in September, and we're very excited to go up to Calgary. We're going up to Canada for the first time this year with one of our regional events, so we will be there in October. And finally, we'll round out the year in Albuquerque, New Mexico. So hope to see you at those as well. And lastly, we do a lot of these webinars. We also have our weekly Fiber for Breakfast webinars we did this morning, every Wednesday at 10 a.m. I'd encourage you to keep your eyes out for topics you might be interested in. And please join us every Wednesday as well for Fiber for Breakfast, which of course is hosted by Gary Bolton, our CEO and president here at FBA. So thank you again to Hexatronic. Thank you, Chad. Appreciate it. And thank you to all of you who have joined. We hope to see you on the next one and hope to see you next week. Have a great day, everyone.